So let's try some basic program. 5 plus 7, 12. Okay, nice. So let's try to print something like run. Okay, here we go. There are many reasons why would you connect your Commodore 64 with a modern PC. From file transfer, go online or connect your Commodore 64 to your favorite BBS, or just use this lovely keyboard for your daily work, whatever you need. And there are many instructions online on how to do it. The only problem is that they are either overcomplicated or just use modules that are very hard to find these days. But here we can do it a bit more simpler and use more commonly available parts. Now, don't get me wrong, any solution that works is great, and every solution has its purpose. So the purpose of this solution would be like the budget solution, maybe. Now, to connect Commodore 64 to a modern PC, we need to take a look at the back of the computer. And here we have UserPort. Here we have some interesting lines that we can use. And what we will use is RS232. Now, RS232 was and still is very common serial communication protocol between devices. But RS232 on Commodore 64 was very much criticized back then. So why? Well, because there is any on Commodore 64. You see, Commodore did not put any proper hardware for serial communications to save costs, and instead use CPU power and software to generate appropriate serial signals. Now, for proper RS232, we need negative voltage to represent the logic high and positive voltage to represent the logic low. And this is very robust method for data transfer. But on Commodore we have 0 volts for logic low and 5 volts for logic high. So what kind of protocol is that? Well, this is what we call TTL serial communication. And believe it or not, this is so much better today than it ever was back then when Commodore 64 was on the market. So, let's check it out. Okay, we have a TTL serial communication here, and on a modern PC or laptop we can be pretty sure that we have a USB connector. And as we know it, USB devices can identify itself as a specific device, like a keyboard, mouse, printer, and so on. So for that reason is why we replace all different kind of connectors and protocols that we used to have on the PC with just USB connectors. So that is very useful. So 0 to 5 volts here on TTL, 0 to 5 volts here on the USB connection. So we are on the same voltage levels. That's good. So to connect the TTL on Commodore 64 to USB on modern PC, we need a TTL to USB converter. And I have one just right here. It's very cheap, very small device. You can find it all over the place. And it comes in variety of versions, but they all works on the same principle, same way. So when we plug it in on the PC, it identifies itself as a virtual serial port or virtual COM port on the Windows machines. And on this left side we have a TTL connection that we connect to Commodore 64. So it's that easy. But if you have some older PC with the classical DB9 serial port, then you can use one of these little converters. They are also very cheap and easy to find on eBay, so I highly recommend it. Now I already wired a USB to TTL converter to edge connector that connects to UserPort on Commodore 64. We use just 3 wires, so it's that simple, and we are ready to do some testing. Now, before that, all these schematics will be available in the video description. And before we do any testing, let's check how two devices communicate via serial protocol. If we want to enable serial communication between two devices, we need at least 3 lines. Two are data lines. First is transmit line, or TX, and second one is a receive line, RX. And these lines are in one directions only. So that means that the transmit line only transmit data and the receive line only receive data. And we have a ground. Now, we need to connect ground lines between two devices to enable data lines to work at all. And two data lines we connect in a crossed way. That means we connect TX line from one device to RX line from the second device and vice versa. Now, if we want to use TTL to USB module, this one, we do not need to use 5 volts power line from Commodore 64 because the chip here is powered via USB connection. Now, in case of TTL to DB9 module, we do need pull the 5 volts from the Commodore 64 because the DB9 does not provide power for this Max 232 chip. Okay, let's hook this up. First of all, we need to plug this to UserPort. I will unplug this cable. So, like this. Okay, that's nice. And then this side goes to PC, but because it's too short, we will use USB extender cable. Dun, 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 dun. Okay, just USB cable, and we'll plug this to my laptop. There you go. So that's the whole setup. Now what we need, and you can see that, I don't know what you see, but there's already power on this little board. So the next thing is connect the cable, and we will need some programs. So we need this little thing. We are ready. Okay, so we have this small little basic program that we just open the device number 2 with this configuration values that I will explain a little bit later, so you don't have to worry about that now. And we are just reading values from that device, and we print them on the screen. So that's all we do on this little program. So if we start this with the run, we get nothing. So we are just waiting. We don't have anything yet on the serial device. So now we are going to modern PC. I don't know how much you see here, but we will do we have our device here. We will open Minicom and we will set serial port on the TI USB 0. Speed is 240. We don't want any hardware flow control. Okay. I'll set echo. Okay, we have echo. So I don't know how much you can see here, but you can see some activities between two devices, I hope. So we have established serial communication. Now we need to switch to, okay, now we have some letters. This is that's nice. Before we continue, I have to explain you a few more details related to serial communication. Now, serial communication has no clock signal or any other mechanism to keep the communication in sync, and we are depending on the correct timing here to receive and send messages correctly. And to do that, we have to know configuration parameters, speed in bits per second, number of bits in packages, parity, duplex, and so on. So both devices need to have the same configuration to be able to understand each other. Now, here are some very useful pages where you can see how to configure and set up serial communications. And all the links will be in the description of this video. Now, this small basic program that you see on the screen is very useful tool to build parameters for opening a serial connection on Commodore 64. There are all these variables that you fill with desired values, and the program builds these parameters, these two parameters that you need to fill during the opening of the serial connection. And if we run it, then we get the values of these two. So this would be 10 and this would be 161. LF is logical file number. You can use it whatever you like. GA is 2. That's the number of the RS232 device on the Commodore 64. So that value is always 2. And the secondary address does not exist, so we will keep it 0. Now here we will load a little program written in assembly language. I'm doing exactly the same thing, reading data out of serial port and outputting it to the screen in a little bit different way. You will see in a moment. So we load the program into memory. We need to start it. I believe it was 4152. Okay, so we are ready to use modern keyboard on a Commodore 64. So let's try this. Yeah, we are ready. So let's try some basic program. 5 plus 7, 12. Okay, nice. So let's try to print something like no, let's try to do, yeah, classic border change color 53280 I believe was. Okay, yeah, that's nice. Now let's try some basic program. 10 print area test this and go to 10. Of course you cannot do. Let's try to see, did we remember this? Yes, and we can run it, and we did not get anything. What's going on? Run. Okay, here we go. So how is this even possible to do? Now first of all, we are using a keyboard connected to a modern PC where we have open serial connection with the Commodore 64, and our little program here is active. It uses raster interrupts to capture any information coming from a serial port, and instead of just outputting directly to the screen, we fill the keyboard buffer of the Commodore 64, and to constantly tell, in case that we have something in the keyboard buffer, we just tell the kernel that there is something there and to process it. So if from the perspective of Commodore 64, all the information that we send this way is exactly like sending it through this keyboard. There is absolutely no difference whatsoever. So that's the way that we are able to um, run these commands and make it execute in the basic. So this is the way that we can use a modern PC to control Commodore 64, and of course we can do the other direction also. So the next thing that we are going to show you is how to use a Commodore 64 to control or to use a modern PC. Okay, let's start the terminal application on Commodore 64, just to find the suitable one, this one I believe. So while this is loading, let's switch to PC side, and here we will do something quite interesting. So we will use a getIC command on the Linux machine, and this will allow us to map a serial port to system console. So what that means is when we connect with Commodore on the serial port on PC, we should able to see login prompt. So I will not go into details of how to set this up, but I will provide the link into description of this video. But just for short information, I did create a special user just for this case, and I enabled auto login, so we will kind of skip this part on the Commodore 64. So once we connect on serial port, we should get automatic login on the system. So before we do that on the PC, let's take a look on Commodore. So the terminal application is loaded. Okay, we are zoom in. So just a quick look at this application, and what we are interested here is dialer parameters. So that's F7. So what we have here is speed 2400 in that's baud rate. Duplex is full, that's fine. Modem type is not very important at the moment. Protocol Panther, okay. So that's all fine for our case. So we just enter return, and we are waiting here. So I'll try to, I don't know how to, I'll try to capture both screens. I don't think that's possible. Okay. So I will try to do this quickly as possible. So, okay. Here I will start. First of all, I will enable, we will use system D to enable to map activate the Getty on the TTY USB 0 serial port, and okay, password. Okay, so we created system link. Okay, we enable it, and now we will start it. And before I press enter here, I would switch to Commodore, and you can take a look what will happen here. So here we go. Okay, and we are logged into PC, into Linux shell. So ls. Okay, and we need to switch to ASCII terminal. So here we should be okay. Okay, so we have two files here. So let's cat one txt file just to see what's in it. So there's some content, and what we could do next is we have one Python script. So let's try to run Python script. Python days.py, and it's executed just fine. So what we can do next is try to oh, and we have some pings coming. So there you go. Okay, let's try to stop that, and let's try to go to Python console. Let's try to write some small program. Return, then we have while one this print j, okay, j plus equal 1, and just one small infinite loop, and we are running. So there you go. So for conclusion, as I mentioned at the beginning of this video, is that serial communication of RS232 on Commodore 64 is more suitable for today use with the modern machines than it was back then, and that's absolutely true. So if you want to, for example, connect Arduino board to Commodore 64, it's very easy. TTL on Commodore 64, TTL on Arduino boards, 5 volts on Commodore 64, 5 volts here, direct connection, no problem whatsoever. Raspberry Pi, of course, same thing. And if you see something that something that is called FTDI for Raspberry Pi and similar boards and small computers. Well, that just this little fellow wants more to connect TTL to USB. So one example of one board is BBC Microbit. So that's this one. This board, it will be more familiar with the viewers from Europe and especially UK, and there is quite a bit story that goes with this board. Also 5 volts TTL, you can connect it directly to Commodore 64. Also in last couple of years there are Wi-Fi modules available for Commodore 64, and what they use is one of these, that's ISP8266 or ISP32. Again, TTL connection directly to Commodore 64 works just great. The only downside of the Commodore TTL connection is actually the speed. So it was very slow back then, and especially very low today. Um, um, in today's demonstration, we used 2400 beats per second, and that's really slow, and that was maximum that we could use. Uh, mm, that's all because of lack of proper hardware, and because the Commodore 64 actually uses CPU um, to handle all the TTL communications. But still, I encourage everyone to connect more machines to Commodore 64 because it's fun, just pure fun. Thank you and goodbye.